On this channel, we provide useful programming information with practical code examples. This time, it's about the basics of TypeScript. It explains an overview of TypeScript, how to run it on Visual Studio Code, methods of variable declaration, and variable hoisting. Enabling subtitles will make the code descriptions easier to understand. Please make use of it. First, we'll run the classic Hello World example in TypeScript using Visual Studio Code. Install TypeScript using the npm command. Create a tsconfig.json file. Create a .vscode/launch.json file to enable running the main.ts file in Visual Studio Code. Create a main.ts file that displays Hello World. You can run it in Visual Studio Code by pressing the F5 key. By configuring this way, you can execute TypeScript files within VS Code. TypeScript TS is a superset of JavaScript developed by Microsoft. TypeScript supports static typing, allowing for more robust and maintainable code. TypeScript adds types to JavaScript and performs type checking at compile time. This allows for preventing type-related bugs in advance. Since TypeScript cannot be directly executed in a browser, it needs to be compiled to JavaScript. Use TSC TypeScript compiler to convert TS files to JS files. TypeScript also performs type inference but allows you to explicitly specify types when necessary. This improves code readability and reliability. TypeScript provides interface to define the shape of objects. This allows for strict management of object structure. TypeScript provides extensions to JavaScript's class syntax and supports inheritance, access modifiers, public, private, protected, and abstract classes. In TypeScript, you can write reusable and type-safe code using generics. TypeScript is fully compatible with the JavaScript ecosystem and can use existing JavaScript code as is. Furthermore, it is integrated with popular libraries such as React and Node.js. TypeScript offers advanced features such as autocomplete, refactoring support, and error checking in editors like VS Code. TypeScript is particularly useful for enhancing reliability and improving developer productivity in large projects. This explains the basic concepts and usage of variables in TypeScript. In TypeScript, variables are declared using three keywords: let, const, and var. Each keyword has different characteristics. Let has block scope, valid only within curly braces. Values can be reassigned later. Const cannot be reassigned, so the value assigned once cannot be changed. However, the contents of objects and arrays can be modified. Var has function scope and can be reassigned. However, ignoring block scope, it may cause unexpected behavior compared to let or const. In TypeScript, you can explicitly annotate types for variables. Type inference is also supported, but type annotations are useful in complex scenarios. If a variable is declared without initialization, undefined is assigned by default. A variable declared with let must be explicitly assigned undefined or include undefined in its type if not initialized. Let and const have block scope, so they are only valid within the same block. Since TypeScript is a superset of JavaScript, it inherits JavaScript's hoisting feature. Hoisting refers to the behavior where variable and function declarations are treated as if they are lifted to the top of their scope. However, only the declaration is hoisted, while the initialization remains in place. Variables declared with var are hoisted, but using let or const before declaration results in an error. In this case, variables declared with var are hoisted, and their values are output. Variables declared with let are not hoisted, resulting in an error. The following is a summary of let, const, and var. Let is reassignable and has block scope. Const is not reassignable and has block scope. Var is reassignable and has function scope. All of them allow explicit type annotation for specifying variable types. Escape characters are used when specific characters cannot be entered directly or to represent characters that have special meaning within a string. In TypeScript, escape characters are used to represent control characters or special characters. For example, use \n to output a message that includes a new line. Escape characters are also useful when including special characters in a string. For instance, you may want to use double quotes or single quotes directly within a string. To include a backslash in a string, you need to write it as a double backslash. In TypeScript, Unicode code points can be represented using escape sequences. You can represent Unicode characters by specifying a 4-digit hexadecimal number after \u. You can represent specific characters using a 2-digit hexadecimal number after \x. Template literals are defined by enclosing them in backticks and provide an easy way to create embedded expressions or multi-line strings. Regular escape characters can be used directly in template literals. In TypeScript, using invalid escape sequences within a string may result in a syntax error. Therefore, it is important to check whether the escape characters are valid. Here is an example of constructing a complex string using escape characters. In this example, \n is used for a new line and \t is used to add indentation. This makes the JSON structure easier to read. Escape characters are very important when working with strings in TypeScript. When you want to include special characters or control characters in a string, you can create expressive strings by using appropriate escape sequences. Understanding and using escape characters correctly can improve code readability and maintainability. Let's take an overview of the TypeScript version here. TypeScript 1.0, 2014. The first stable version of TypeScript. Basic features such as typing, classes, and modules were introduced. TypeScript 2.0, 2016. Non-nullable types, control flow analysis, read-only properties, and never type were introduced, enhancing type inference. TypeScript 3.0, 2018. A more flexible type system was introduced, with features like project references, tuple types, extensions, and improvements to REST parameters. TypeScript 4.0, 2020. Features such as variadic tuple types, editor improvements, enhanced type inference, and labeled tuple elements were added to improve the development experience. TypeScript 4.1, 2020. Template literal types were introduced, making string type manipulation more powerful. TypeScript 4.3, 2021. The addition of the override keyword, improvements to access modifiers within constructors, and enhanced type support for weak map and weak set. TypeScript 4.5, 2021. The awaited type module suffixes and improved compatibility with ECMAScript modules were added. TypeScript 5.0, 2023. Standardization of decorators, improvement in project build speed, enhancement of type system, and support for the latest ECMAScript features have been made. TypeScript is constantly evolving, with multiple versions released each year introducing new features and improvements. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. If you enjoyed this video, please consider subscribing to the channel and giving it a thumbs up. Thank you for watching.